Got one question for you. We got a problem. Water, the drinking water or water that we all know it. Is water acidic or basic? Is water acidic or basic? Some of you like, what? I thought water is neutral. Well, it's a little complicated. It's the same answer that you give when someone asks you, hey, are you guys still dating? And you be like, it's complicated. There's just many things involved. His mom, my dad, and his friend, my best friend. No, just a lot of it. So it's really complicated. All right. Let's take a look here. So let's talk about it real quick. Water. Let's look at the liquid water in the molecular level. Okay, so all water floating around, and they just one slide off each other, just liquid form, and all of them from hydrogen bond to one another. Look like that, hydrogen bond. Okay, and now I want you to focus on this hydrogen bond right here between these two water molecules. All right, when it's these two water molecules from hydrogen bond, they can get really close. And the proton, so this proton here, look at this proton, can hop from one oxygen to another oxygen. So hop to another water molecule, basically. And from hydronium ion and hydroxide ion, okay? And it can hop back and forth, right? So this process is called proton transfer, okay? But basically, all acid-base reaction is called proton transfer, right? The proton transfer occur really, really fast. How fast? 1.3 times 10 to the 11 per molar per second, really, really fast per second, okay? And it doesn't have to happen just these two molecules. Look at these water molecules right here. This proton can hop onto another from hydronium ion and hydroxide ion. Can happen here, can happen here, can happen back there, can happen here. I mean, just everywhere could happen, right? So, is water acidic? Well, we have to talk about how much hydronium ion or hydroxide ion are formed in water. Does it make sense? If the water molecule, if a glass of water have a lot of hydroxide ion, that's a base. It's a basic solution. If a glass of water has a lot of hydronium ion, that's an acidic solution. All right, so we call this self-ionization of water or auto-ionization of water. This happened, just happened. That happened right away. Any water have this happen. So two water molecules, so one hydrogen hop on to another water molecules and become hydronium ion and hydroxide ion. Okay. All right. Can you express the equilibrium constant of this equilibrium? Right. KD is a dissociation. Well, same thing with KC. All right. KD equal to the product concentration of the product over concentration of reactant, right? But some of you like, oh, hold on, there's a liquid right here. Well, we don't really include it, but I'm going to show you. Water is a solvent, so the concentration never change. So I'm moving water to the left side, right? Times water on both sides, you get this guy right here. The concentration of water is constant, KD, which is a constant as well. So we got a new K, we call KW. That's the dissociation constant of water, okay? Equal to concentration of acid and the concentration of base, all right? So that's KW. Experimentally, we found that the concentration of proton and hydroxide ion in water are equal and not a lot, only 10 to negative 7 molar. It's really, really small. If you plug in right here, so the value of KW is 10 to the negative 14. You know? Well, guess what? I guess water is neither acid or base then, neither acidic or basic. All right? Because KW is really, really small. It's 10 to negative 14. Totally, this equilibrium favor the formation of the reactant, not a lot of product there. Okay, so water is neither acid or base. But it got some proton or hydronium ion and hydroxide ion, just a little, not a lot. It's really, really small amount, right? But this happened. KW is always 10 to negative 14, never ever change. Okay, it's at constant temperature. Unless you change the temperature, can't change. Anyway, so KW doesn't change, right? Let's say if you add some acid in there. Let's say I add hydrochloric acid, and the final concentration of hydronium ion is 10 to negative 6 molar. So add 10 times of concentration of hydronium ion. Okay, what happened is, well, KW never change. We have higher concentration of proton, right, or hydronium ion. Which, well, if KW doesn't change, the amount of this is higher, what's going to happen to the concentration of hydroxide ion? Going to be lower. These two have to control, keep Kw the same. But mathematically, if Kw, if on one side is constant, the other side, if one is higher, the other one has to be lower. Okay. All right. I'm going to plug in real quick. So, I'm going to find concentration of hydroxide ion. All right. So put move hydronium ion down here. So Kw plug in. So 10 to negative 14 at the new concentration. So hydronium ion is 10 to negative 6 molar. Everything cancel out, is 10 to negative 8. If you look at the concentration of acid and base, so right now the concentration of acid is higher, about 100 times higher than the concentration of base. The solution that have higher concentration of acid we call acidic solution. Well, we just add an acid, right? That's why this becomes an acid solution. Since Kw doesn't change, the concentration of proton is higher. The concentration of hydroxide ion is lower. If we do the other way around, let's go back to a normal water, okay? Now, if I add a sodium hydroxide, which is a base, add some base in there, all right? So, again, Kw is constant, never change. If you add a base, so the concentration of hydroxide ion is higher, what's going to happen to the concentration of hydronium ion? It's going to be lower, right? It's going to be lower. And we call this concentration a basic solution because the concentration of base is higher than the concentration of acid. All right. So what you should get from what I just explained to you is the concentration of acid and the concentration of base are linked by Kw. That's the mathematical explanation. Okay. So concentration of acid, concentration of base are linked by Kw. If you know concentration of an acid with Kw, which is 10 to the negative 14, you should be able to find the concentration of a base and vice versa. All right. All right. Let's practice this with me together on the next video. Okay. All right. Do on your own first and then check with me on the next video.